Okay. So we have a situation, 102 miles, 102 mile trip. We go, we come back. Takes 7 hours longer coming back than it does going. And the average speed coming back is 2 miles an hour less than it was when we were going. So how fast are we traveling in each direction? Well, yeah, how fast we're traveling in each direction. Instead of writing X's and stuff to start with, it can be helpful to just write the relationships in words. So if we write it this way, didn't leave myself enough room, but the average speed back is the average speed going minus 2 miles an hour. That's the fundamental thing. And now that we have that information, we take, the simplest information we can get out of the problem is this given relation between the average speed going and average speed coming back. Now we can use the time because we know how average speed is related to time. Okay, so the average speed back is what? It's, well, let's let X equal the time going. Now that's simpler than saying how fast each way. It's going to be simpler to set the problem up in terms of one of the times than in terms of the speed, which requires dividing a distance by a time. Okay, so let X equal the time going, then the average speed back well, actually, let's do the average speed going is under 2 miles over X. And the average speed back, well, that's going to be the distance divided by the time back. So that's going to be 102 miles over the time it takes to get back, which is X plus 7. So now that we know the average speed back is the average speed going minus 2 miles per hour, we can say 102 miles over X plus 7 hours equals average speed going, which is 102 miles over X minus 2 miles per hour. Then we solve this. Now we probably, when we solve it, we don't want to write the miles and the hours, but let's make sure that those units work. Okay, this will have units of miles over hours because the 7 is 7 hours, right? And the X is going to be time, so X is going to come out in hours. And here you got miles over X. X is again your time, and when you solve it, X is going to come out in hours, and this is miles per hour. Okay, so every one of these expressions has units of miles per hour, and it's always good to check that. If you have an error in your thinking, something's going to go wrong. Okay, if you think you subtract 7 hours here, or add 7 hours over here in the numerator, then the units aren't going to be the same on all of the expressions. Okay. Okay, so now we have to solve this thing, and of course, that's not for the faint-hearted, but who's faint-hearted in this room? No faint-hearted people here. We're going to solve it. 102 over x plus 7 equals 102 over x minus 2. Now to solve this, it's an equation with denominators. Denominators are a pain in the behind when we're doing an equation. So we do our best to get rid of them, but we do it carefully. Okay, so we're going to take a common denominator. And since we got fractions, I'll use x times x plus 7 over 1. I don't think everyone in here needs to do it that way, but some probably do. And we have and again, I thought I had plenty of room, but I never do. Okay, x times x plus 7 times 2. So we multiplied every term by our common denominator, and that has the advantage that, look at what we can do here. We multiply out the numerators, we're going to have an x plus 7. We multiply out the denominators, we're going to have an x plus 7. So we can think of switching the 1 and the x plus 7, since they're multiplied, we can do that. So we have an x plus 7 here. We'll divide this x plus 7 and just leave us x. Now, some people like to cross these out. Yeah, you better be careful about the rules because I see bad cancellations. It's an epidemic. Okay, way more people suffer from bad cancellation than they've ever suffered from COVID. COVID is bad enough. Okay. Well, maybe the consequences of your health are more important to you than the consequences to your mathematics still. Okay, let's do that. Well, we can do something similar over here, and we end up with x plus 7 times 102. Now here we have x times x plus 7 times 2. Well, if we multiply that out, I'll do it in 2 steps. X times x plus 7 is clearly not x squared plus 7, it's x squared plus 7x. And then we can complete expanding all this. We get 102x plus 714 over here. And then when we multiply all this by 2, we're going to get a 2x squared and a 14x. Of course, we've got a minus, so it's going to be minus 2x squared minus 14x. And now we recognize, hopefully, the red flag goes up and say, okay, that's a quadratic equation. We got x squared, so we got x's, and we got constant terms. Okay. So what we want to do is get everything onto one side. Well, if I'm not sure I want to do it all at once. Well, I'm going to do this. Okay, 102x equals 102x minus 14x is 88x. And then if we subtract all this from both sides, we get 102x minus the quantity 88x plus 714 minus 2x squared equals 0. Well, that means then we have 102x minus 88x minus 714 plus 2x squared equals 0. And 102x minus 88x is 14x. And we have this form, and then we probably want to go ahead and put these in order so we don't go blind looking at the quadratic formula. And there we have it. So x is going to be negative 14 plus or minus the square root of b squared, which is 196, minus 4ac. Well, 4 times 714 is 2856. So we get 56. Okay, I'm losing my numbers. Okay, it was 56. Okay, 2856. So we get 5712, I think. And that's negative. It's going to make this positive. And that's going to be over 4. Okay, now if I've got the numbers correct, I'm just going to approximate this. 196 and 5712 is going to be 5908. 5908 would have a square root of about 76, 77. Negative 14 plus 77 would be 53. 53 over 4 would be about 14. Did that in my head. But let's see if it checks out. And or of course, negative 14 minus 77 is negative 91. 4 goes into 91 about 20, almost 23 times. Now this would be miles per hour, and we know that we don't go negative 23 miles per hour because we're talking about speed, not velocity. If we're going to go into the idea of velocity and get negative times and stuff like that, it doesn't correspond to the real world. So we discard this. Okay, but we have this. Now we can check it. 102 over 14 is a little more than 7. 102 over 21. 14 plus 7 is 21. 120. 102 over 21 is a little less than 5. So that's around 7. And this would be around 5. Average speed going about 7 miles an hour, average speed back about 5 miles an hour. If you do all the calculations correctly with your calculator, you should get exactly 5 mile an hour difference. Now, in one solution I saw, I think maybe that 14x got lost. Okay. Because I think I saw everything else. And it didn't quite work out. Got a little bit of a higher number here, something like 18. So it was well done, but the devil's in the details, and the devil bit most of us a little bit in the case of this problem. I probably got a detail wrong in my calculations here. Of course, that's just an approximation. But there we have it. Again, to kind of summarize, I think it's worth summarizing. We symbolize or identify first and then symbolize the quantities in the problem. And the first and probably most obvious one is the average speed is 2 miles an hour less going than coming. Yeah. Okay. So we write that and kind of focus on this. Then we have to do something with speed. Since we have this information. So we got to do something about the average speed back and the average speed going. Well, we use the fact that speed is distance divided by time. And let x be the time going. So we got 102 over x. That's going to be our average speed going. Coming back. We got to take 7 more hours. So the time is x plus 7 hours. And it's going to be the average speed coming back from the 102 miles over x plus 7 hours. So there we have the equation. And then we try to dodge all the mines in the minefield of the solution to get down to something that checks out. And all this is standard equation solving, but there are plenty of pitfalls here. It's easy to forget to put. Remember, I started writing a 7 instead of a 7x there. If I'd have kept that, oh, there goes my 14x. Okay. And that also could slightly change to 714. So all kinds of things can go wrong. But we do it carefully, we check, doesn't work, we go back and do it again. We look for errors, or maybe we just start over. Sometimes you're so locked into an error. If I was convinced that should be a 7 there, you might never spot that should be a 7x unless I go back and do it again, preferably a little bit later when I've kind of forgotten all the things that I got into my head when I did it first time. Make sense? Mm-hmm. Okay, good. Okay, I'm going to cross this out for a moment. It's an ambiguity, I think, in either my understanding of a certain problem or in the statement of the problem, and I'm not doing a good job of figuring out that ambiguity. So I'm going to move on to this situation. We've got an 11 by 17 piece of paper. Now, this is half the size of that 11 by 17 paper, and I had to tear these off because I'm not sure where my scissors are, but we tore corners off of this thing and then we folded it up into an open box. Okay. So if we'd have started with an 11 by 17 piece of paper, we would cut away equal square corners, fold it in an open box. The volume of the box is 300. What are the dimensions of corners? Okay, so after some discussion and the idea of, okay, well, we know the volume's length times width times height, and we're in a quadratic function chapter, so we've got to get a quadratic, but that comes out of doing it, but you kind of know that, you kind of anticipate that's not a bad thing. And then we started saying something about X, but never said what X was. Now it's obvious what X is, but let's write it down. Well, let X be the length and width of the missing corners, right? Now, what is it that we're trying to find that we could write in terms of X? Okay, so what I'm saying is there's a nice picture. I didn't need it to get out a microscope to see it, but it was there and it was nicely drawn. If it was enlarged, it would look really good. And I'm sure it looks really good small. Okay, so what you say is, well, we got X here, and we got X here, and we got X here, and we got X here. So we put that into our picture. Now we want to go ahead and put what I'm hearing is, okay, do we have 11 minus X or what do we have? Okay. Well, if we go to the picture, we see that the base is going to be right here. Now, in terms of the information we have, what are the dimensions of the base? Okay, so we've seen this pretty quickly, that this is going to be, actually that'll be 17 minus X, the way I've drawn this. And this will be, and if not minus X, it's minus 2X. Okay. Dimensions. For the base, 11 minus 2X, 17 minus 2X. So what's the volume? Well, when you fold it up, the sides are going to have length X. So your volume would be 11 minus 2X, X times 11 minus 2X times 17 minus 2X. And that then tells us that X times 11 minus 2X times 17 minus 2X equals 300. Now, at this point, this isn't quadratic. This is cubic. So that becomes much harder to solve, but that's how you could set up the typical problem of folding up the edges of a box.